Third topic is triangles, and for the point of examination it is very important topic. In this topic we are dealing with the concept of similarity. Last year we have seen the concept of congruency, means two triangles are congruent if their corresponding angles are equal as well as corresponding sides are also equal. Means if both the triangles have corresponding angles equal and corresponding sides also equal, then and then the two triangles are congruent. Here we have to see the similar triangles. When the two triangles are similar, means what are the conditions of the similarity of the two triangles? So before going to see the similarity of the two triangles, we will see the similar polygons. Means the two polygons are said to be similar to each other if first condition is that their corresponding angles are equal and the lengths of their corresponding sides are proportional. For congruency, the first condition for the congruency as well as similarity, the first condition is the similar, that is their corresponding angles are equal. This condition is for similar triangles as well as for congruent triangles. But we know that two triangles, the second condition for the two triangles, they should be congruent, is that the length of their corresponding sides must be equal. But for the similarity, the lengths of their corresponding sides must be proportional. Means angles should be equal, corresponding angles should be equal and corresponding sides must be proportional for the similarity of the two triangles. So this is the main condition, these two main conditions for the similarity of the two triangles. For example, if we consider the two polygons A, B, C, D, E and P, Q, R, S, T. So these two polygons are similar, then from the above definition their corresponding angles are equal. Means here angle A, angle B, angle A equal to angle B, angle B equal to angle Q, angle C equal to angle R, angle D equal to angle S, and angle E is equal to angle P. So the first condition is that their corresponding angles are equal. Now we will see the second condition. The second condition is that the length of their corresponding sides are proportional. Proportional means the ratio of the corresponding sides should be equal to the ratio of another corresponding sides. Here AB and PQ. AB and PQ, these are the corresponding sides. So AB upon PQ is equal to the next corresponding side is BC and QR. So AB upon PQ is equal to BC upon QR. Then CD upon RES, CD upon RES equal to DE upon SD, DE upon SD, and the last one, that is EA upon TP. EA upon TP means the ratio of all the corresponding sides must be equal. Then and then the sides are called to be in proportional. Understand? So this is the second condition for the similarity of the two polygons. Here, if these ratios are equal, then we say that corresponding sides are proportional. Now, therefore, and if the two conditions are satisfied, then and then we can write that A, B, C, D, E similar to P, Q, R, S, T. Means polygon ABCD is similar to polygon P, Q, R, S, T, and the symbol of this similarity is like this. So this symbol stands for the similarity. So in this way we have seen the concept of similarity of the polygons. Now our main point which we are going to study is that similar triangles, means similarity of the two triangles and the properties of the similarity or the properties of two similar triangles. Here, two triangles are said to be similar if the first condition, that is corresponding angles are equal. If corresponding angles are equal, and second, their corresponding sides are proportional. Same conditions are here. Means if these two conditions are satisfied, then the two triangles will be similar to each other. Here, for example, we will see the two triangles here, A, B, C, and triangle P, Q, R. Here angle A is 70 degree, angle B is 60 degree, and angle C is 50 degree. Then here angle P is 70 degree, angle Q is 60 degree, and angle R is 50 degree. Then the corresponding sides means AB equal to 2 centimeter, BC equal to 4 centimeter, and AC equal to 3 centimeter. Here in a triangle PQR, PQ is equal to 4 centimeter, then QR is equal to 8 centimeter, and PR equal to 6 centimeter. And now we will find whether the two triangles are similar or not. First, we have seen that whether the corresponding angles are equal or not. Here we will see that angle A is 70, angle B is 70. So A equal to P, angle A equal to angle P. So we got here angle A equal to P. Then angle B is 60 degree, angle Q is 60 degree, and therefore angle B equal to angle Q. So we have written here angle B equal to angle Q. Then angle C 50, angle R 50, and therefore angle C equal to angle R. Angle C equal to angle R. So it is seen that the corresponding angles of both the triangles are equal. So first condition is satisfied here. Here we have seen the definition of the similar triangle, and in that definition the first condition was that the corresponding side angles are equal. So we are satisfied. Here first condition is satisfied. Now we will see the second condition, that the corresponding sides are proportional or should be proportional. Here length of AB 2 cm, length of PQ 4 centimeter. So AB upon PQ, we will see here AB upon PQ is equal to 2 upon 4, and if we reduce, we will get 1/2. So that is equation number 1. And now we will see the another, that is AC upon PR. AC upon PR is AC is 3 centimeter, PR is 6 centimeter. So AC upon PR is equal to 3 upon 6. Again, after reduction, we will get the value 1/2. So that is equation number 2. And now the ratio of the third side, that is BC upon QR. Here BC is 4, QR is 8, and therefore BC upon QR is equal to 4 upon 8. After reduction, we will get here 1/2. Here, if we find the values of RHS of equation 1, 2 and 3, we will get AB upon PQ is equal to 1/2, AC upon PR is equal to 1/2, and BC upon QR is equal to 1/2. Means all the three ratios are equal. Means therefore from equation 1, 2 and 3, we will get AB upon PQ is equal to BC upon QR is equal to AC upon PR, because RHS is equal and therefore LHS must be equal. In this way, it is seen that our second condition, that is the corresponding sides are proportional, is satisfied. Here corresponding sides are proportional, and in this way, from our two conditions, where the two conditions are satisfied here, and therefore we can write that triangle ABC similar triangle PQR. Means here we have seen how to find the two triangles are similar or not. Here mind you that here each triangle has total 6 parts. Here 3 angles, 1, 2, 3, 3 angles and 3 sides. Means 3 angles plus 3 sides means 6 parts are there. Means 6 parts of one triangle should satisfy the condition with the 6 part of the another triangle. So in this way, we have seen about the similar triangle or similarity of the triangle. We shall discuss some basic results on the proportionality, and these results are nothing but the theorems. These results or these properties are nothing but the theorems. So first theorem we will see here, and that is known as basic proportionality theorem, that is BPT. B for basic, P for proportionality, and T for theorem, that is BPT, basic proportionality theorem, or this theorem is also known as Thales theorem. Thales, Thales theorem. So this theorem states that if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides. It means that line divides the two sides in the same ratio. I will repeat the statement, that is, if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the two sides in the same ratio. Here, if we consider a triangle A, B, C, and in this triangle DE is the line which is parallel to the another side or third side, that is BC. So DE is parallel to the side, one side of a triangle, and that side is BC. So DE parallel BC. So it is given that if a line is drawn parallel to one side, means DE is line drawn parallel to one side BC, and intersect the two sides in the two distinct points. That is, DE intersects AB in a D, while DE intersects AC in a E. So it is given that the line is drawn parallel to one side of the triangle, intersecting the other two sides. Then it divides. It divides means DE divides the two sides in the same ratio. In the same ratio, what is the division of AB? AB divides means AB and DB. These are the two parts. So AB upon DB, and the other two parts of the AC, that is AE and EC. So AD upon DB equal to AE upon EC, and this is known as the sides are divided in the same ratio. If we take the ratio of these two parts, that is AE upon DB, similarly AE upon EC, then both the ratios are in the same ratio, or they have equivalent value, and therefore it is said that the line divides means DE divides these two sides, that is AB and AC, in the same ratio, and therefore we have to prove that AD upon DB equal to AE upon EC, and therefore we have to first consider given of this theorem. And we know that in given we have to write the information of the diagram according to the given statement. That is, if a line is drawn parallel to one side of a triangle. So which is your triangle? So in a triangle ABC, our triangle is ABC, and therefore in a triangle ABC. Now a line is drawn. Which line? DE line is drawn parallel to one side. Which side? DE is parallel to DC. Means DE is parallel to DC. Then it is, we have again given that DE intersects AB, means DE intersects AB in a point D, and AC in E, and so this information of the diagram or figure is known as given. And now we have to prove that it divides. It means the line, which line? DE, line DE divides the two sides in the same ratio, means AD upon DB is equal to AE upon EC, and that is our to prove AD upon DB is equal to AE upon EC. Now there is construction. The construction is shown by the dotted lines here. Here we have drawn EF perpendicular to AB. Similarly, draw another perpendicular DC perpendicular to AC. Means EF perpendicular to AB and DC perpendicular to AC. Means this EF is perpendicular to AD and DC is perpendicular to AE. Here, if we consider the triangle ADE, if we consider a triangle ADE, and in this figure we have drawn the perpendicular EF. So AD is the base and EF is the height of the triangle ADE. Understand? So we know that area of the triangle is equal to 1/2 base into height. Then area triangle ADE, it will be 1/2 into base is AD into height is EF. Similarly, if we consider the height BC, consider the height BC. Then base will be AE, and therefore area triangle ADE, it will be 1/2 into base into height, that is equal to 1/2 into base is AE and height is BC. In this way we can write the area of triangle ADE in two forms. Understand? So construction is there. What is construction? Join BE and CD. Here BE and CD are the construction is join. You have drawn segment BE and CD which are drawn here. Now another, draw EF perpendicular to BA. Just now I have told you that draw BF, draw EF perpendicular to BA. So EF is perpendicular to BA or AB and BG is perpendicular to AC. So this is our construction, and now we will see the proof. It is given that in a triangle ADE, EF perpendicular to AD. Here EF is perpendicular to AD, and then we can write the area of the triangle, that is 1/2 into base. Here area triangle ADE is equal to 1/2 into base into height, that is equal to 1/2 into, if height is EF then base is AD. So we have written here 1/2 AD into height is EF. And also we know that here if we draw a triangle like this, so this is the triangle, and if we produce QR RQ and draw PS perpendicular, then area of the triangle PQR, it will be 1/2 base is QR into height will be PS. So similarly here BDE is a triangle, and here EF is the height, and BD is the base. In this way, here in a triangle DBE, that is equal to 1/2 into DB. DB is the base and height is EF. So height is EF, and therefore if we take the ratio of both the areas of the triangle, then we will get here area triangle ADE upon area triangle DBE is equal to 1/2 AD into EF upon 1/2 DB into EF. Here 1/2 similarly EF will get cancelled, and we will get the ratio AD upon DB, and therefore area triangle ADE upon area triangle DBE equal to AD upon DB, and this is equation number 1. And now we have to consider the another position of the triangle, that is we have to consider now the height is BC, then base is AE, and therefore we have area triangle ADE is equal to 1/2 base is AE, 1/2 base is AE into height is DZ, divided by, here if we consider triangle CDE, here CDE, and now here CBE, then base is EC and height is DG. So here area triangle CDE is equal to 1 half into EC into DG. Here 1 half and DG will get cancelled. We will get AE upon EC. So equation 2 is area triangle ADE upon area triangle CDE is equal to AE upon EC. But we know that triangle DBE and triangle CDE, here these two triangles means triangle DBE and triangle CDE are on the same base D, and between the same parallels, and last year we have seen that if the two triangles are on the same base and between the same parallels, then both the triangles have same or equal area, and therefore our triangle DBE equal to area triangle CDE. So these two triangles have equal area. And now if we take reciprocals, that is area triangle DBE, and reciprocally it will be 1 upon area triangle DBE, and reciprocal of triangle CDE it will be 1 upon area triangle CDE. And now we have to multiply both the sides of this equation by area triangle ADE, means area triangle ADE. Then we will get area triangle ADE upon area triangle DBE equal to area triangle CDE upon area triangle ADE upon area triangle CDE. Here it is seen that from equation 3 the both RHS LHS are equal. From equation 3 it is seen that both LHS are equal, and if the LHS are equal then RHS must be equal, means AD upon DB equal to AE upon EC, and therefore AD upon DB equal to AE upon EC. This is from equation 1, 2 and 3. In this way we have proved the theorem, that is basic proportionality theorem, which is also known as Thales theorem. Now related to this DPT, there are two corollaries, and we will see now in a triangle ABC, AD parallel BC, in a triangle ABC, AD it is given that in a triangle ABC, AD parallel BC. Sorry, DE parallel BC is given. DE parallel BC. Then we know that if a line is drawn parallel to one side of a triangle intersecting the two sides, then it divides, means this line divides the two sides in the same ratio, and therefore AD upon DB is equal to AE upon EC. Now here it is given that in a triangle ABC, DE parallel BC, then first we have to prove that AD upon AD equal to AC upon AE. This is the NCERT question. And second, AD upon DB is equal to AC upon EC. Here, since it is given that in a triangle ABC, AD parallel BC, and therefore by basic proportionality theorem we can write here AD upon DB is equal to AE upon EC. That is given. And now taking the reciprocal, we will get here DB will go upper side and AD will come down. So we will get here BB upon AD equal to EC upon AD. EC upon AD. And now adding 1 to both sides, we will get 1 plus BB upon AD is equal to 1 plus EC upon AD. Here we can write here 1 upon 1, here also 1 upon 1. But for the addition on both the sides, denominators are not same. So we have to cross multiply. Then we will get here AD into 1 is AD plus BB into 1 is BB. So AD plus BB divided by AD into 1 is AD. So AD plus BB upon AD equal to here also AD plus EC upon AD. And now we know that AD plus BB that is equal to AB, that is equal to AB, and AE plus EC that is equal to AC. Then we will get AC upon AE. In this way, we have proved our first corollary. The second corollary is that AB upon DB is equal to AC upon EC. Here, in a triangle ABC, it is given that DE is parallel to BC, and then we have to prove the corollary that AB upon DB is equal to AC upon EC. So let us see the proof of this corollary. In a triangle ABC, DE parallel BC, it is given, and if one line is parallel to the one side of a triangle, then according to DPT we can get AD upon DB is equal to AE upon EC. Here AD upon DB is equal to AE upon EC. And now adding 1 to the both sides of the equation, we will get AD upon DB plus 1 or 1 upon 1 is equal to AE upon EC plus 1 or 1 upon 1. And now for the addition, there are no denominators are not same, so we have to cross multiply. AD into 1 it will be AD plus DB into 1 it will be DB divided by DB into 1 is again DB is equal to AE into 1 AE plus EC into 1 EC divided by EC into 1 again EC. But we know that AD plus DB from the theorem, AD plus DB that is equal to AB. So AD plus DB is equal to AB divided by DB, and that is equal to AE plus EC that is equal to AC. So AC upon EC. In this way, we have to prove that if a line is drawn parallel to one side of a triangle, then AB upon DB is equal to AC upon AC. Here, we have seen the basic proportionality theorem and its corollaries, and now we will see the converse of basic proportionality theorem or BPT. Here, theorem 2, that is converse of basic proportionality theorem. And this theorem states that if a line divides the two sides of a triangle in the same ratio, then the line is parallel to the third side. Means here, if this line DE divides the two sides of the triangle in the same ratio, means AD upon DB is equal to AE upon EC. Means this ratio is equal due to the line drawn into the triangle ABC. So this ratio is equal due to the line DE drawn in the triangle, and therefore if these two ratios are equal, then DE is parallel to BC. DE is parallel to BC. Means if a line divides, means DE divides. If DE divides the two sides AB and AC in the same ratio, in the same ratio, then this line must be parallel to the third side, and this theorem is known as converse of DPT or converse of basic proportionality theorem. Here, to understand or to prove this theorem, we have drawn a diagram, that is in the figure A, B, C is a triangle, and here line here divides side AB into D and side AC into E. Means DE divides the sides AB and AC here in such a way that both the ratios are equal. Means here AD upon DB is equal to AE upon EC, and then we have to prove that this line DE or line here is parallel to BC. Means if a line divides the two sides of the triangle in the same ratio or equal ratio or in proportion, then the line must be parallel to the third side of the triangle. Here we have to write given. Given means I have just told you that given is information about the figure. Means in a triangle ABC, a line here intersecting AB in D. Here line here intersecting AB in a point D, while AC in a point E. So in such a way that AD upon DB equal to AD upon EC. Means the line here is dividing the two sides in the same ratio, and therefore now we have to prove that the line here is parallel to BC or DE is parallel to BC. So to prove L parallel BC, that is the DE parallel BC. And now proof. Here if possible, let DE is not parallel to BC. It is supposed that this DE is not parallel to BC. It is not parallel to BC, or line here is not parallel to BC. So there must be another line. There must be another line which is parallel to BC. And let us suppose DF, line DF is a parallel to BC. Though it is not seen parallel, we have assumed that DF is parallel to BC. And now, just now we have learned the basic proportionality theorem. If a line is parallel to the one side intersecting the other two sides, then it divides the two sides in the same ratio. Means here DF is parallel to BC, and therefore we can get AD upon DB is equal to AF upon FC. Here we get, if possible, let D is not parallel to BC, then there must be another line parallel to BC. Let DF parallel BC. Means in a triangle ABC, since DF is parallel to BC, then by DPT we can write AD upon DB is equal to AF upon FC. AD upon DB is equal to AF upon FC. So that is equation number 1. Now in a given, it is given that AD upon DB is equal to AD upon EC, but AD upon DB is equal to AE upon EC. So that is equation 2, and this is given. So from equation 1 and 2, LHS are equal. This AD upon DB, here also AD upon DB, both the LHS are equal, and therefore both the RHS must be equal. Means AF from equation 1 and 2 we can write AF upon FC is equal to AE upon EC. And now adding 1 on both the sides of the our equation, we will get AF upon FC plus 1 or 1 upon 1 is equal to A upon AC plus 1 upon 1 again. Since the denominators are not same, we have to cross multiply. Then AF plus FC divided by FC is equal to A into 1 is A plus EC into 1 is EC divided by again EC into 1 is EC. So we get here AF plus FC. If we observe the figure, AF plus FC, that is equal to AC. So we will get here AC upon FC is equal to AE plus EC, again AE plus EC, that is equal to AC. So we will get here AC upon EC. Now here taking converse inverse of the both the equations, we will get here FC upon AC is equal to EC upon AC. Now here AC is divided, it will multiply on the other hand, and therefore FC is equal to EC upon AC into AC. Here AC will get cancelled and we will get FC is equal to EC. FC is equal to EC. But if we observe the figure, then it is seen that F and E both are the two distinct points. Both are the two distinct points. Means FC, length of FC is greater than the length of EC. Length of FC means FC is greater than EC, and we have proved here that FC is equal to EC. So it is not the possible. It is not possible, and it is only possible if F and E are not two distinct points. Means F and E must coincide each other. Here, then and then FC is equal to EC is possible, and therefore DF is the line here. DF is the line here itself, but DF parallel BC. DF is parallel here. DF is parallel BC. Means L is parallel to BC. In this way, we have proved the converse of BPD, that if a line divides the two sides of a triangle in the same ratio, then the line is parallel to the third side, and this is known as converse of BPD. So here we have seen the two theorems, that is, first is basic proportionality theorem and another is converse of basic proportionality theorem.